Okay.
Yes. Okay. So, uh, yeah. All right. Uh, fine. Uh, so today we shall go to module 5. Okay, which is on Cad Cam integration. Right. So till now we have seen about the hardware, software that is required for the our CAD and CAM things and how they process the display and some calculations regarding scaling and other things. So now we shall see about the next thing is about the integration part, which is also an essential feature because as we have seen, uh, uh, the once the part is being created using a CAD software, then it has to go to the design department. It has to be meant for analysis, and then it also has to go to the production department and to the manufacturing shop, that is the machine shop, where the subsequent data that has been prepared from the CAD file has to be passed on with complete details, which is very much essential so that the other departments who are going to continue based on the CAD file that has been received for further processing and getting the actual product. Okay, right? So there are a lot many more steps that is required. So thereby, this CAD CAM introduction is a very much important feature. Okay. So yes, so that is what is actually stated over here. I'll just read it. After a part has been designed, it has to be converted to a finished product. But for this, we need a CAD tool and also a CAM tool, right? That is for manufacturing softwares also we need. So this typically consists of, for the CAM software, which includes the major component is this, the computer aided process planning. So whether once the drawing has been made using a CAD file and analysis is over, and then it is going to go to the process planning. So how should this product be processed? Which are the machining operations that it has to undergo? What are the sequence? So all these things has to be planned so that it has to be where this plan, where it has to, where the product has to be built according to this plan, okay, which is going to be made use by various departments once again, okay, right? So we will see which are the departments that depend upon this computer-aided process planning. Yeah, right. So whether the next thing is that though we see the name or just the CAM, we only understand that it is only regarding the using of NC machines, but it is not just restricted to that. So depending upon in every factory or industry, not all machines will have the NC software, or it will be a CNC machine. So whether it is with a CNC machine or not. So that is only one small part where computer programming also has to be done. But apart from that, the production phase, the inspection software is also there. And then softwares for programming the robots, like pick and place robots and so many other things where the robots are being used in the industry. So for all these things, this CAD file is going to be the first step, and it has to be matched or integrated with the CAM files where the NC programming, robotics, right, robot programming, and all these things comes into picture. Right. So the next thing is it has previously it was in the development stage where the integration between the CAD and CAM. Nowadays, due to the advancement of technologies, we have to strengthen it because we need to have the increase in productivity, okay, and to compete in the global markets, right? So the demand is increasing, so we have to cope up with that demands. Only then the industry can survive in the market, right? So then they have to go in for need to automate the process planning because there are so many parts that comes into picture when it is an industry. So it has to be it has to be planned in a very much better way so that we get the products at the quicker time. So this bridging between the design and the manufacturing departments is very important. So for this, how should this manufacturing be processed, or how should it be carry forwarded? This thing should be there, right? Okay, right. Yeah, yes. So this is about the introduction to the CAD Cam integration. So next we shall see about an overview of the discrete product cycle, production cycle, right? An overview. So here, first thing is that when it comes to manufacturing, we can classify this as discrete part manufacturing, okay? And the next thing is about continuous process manufacturing. There are two types of manufacturing that takes place. Okay, one is the discrete part, the other one is the continuous process. Okay, now in the discrete part, what does it say is that the product undergoes finite number of production or assembly operations. Okay, so that means in this case, for what are the part that is going to be prepared or manufactured, it has got a finite number of operations. Everything is being decided in the first time itself, carefully looked upon every step. What is the sequence of in which the operations has to be carried out, right? Everything is being looked apart, okay, from the discrete part of manufacturing. That is one way, right? The other way is about the continuous process manufacturing. So in this, what happens is that in continuous process manufacturing, the product undergoes continuous changes, right? Continuous changes such as chemical reactions, transform the raw materials into final products, right? So depending upon this, what has been done is that there are certain cases where the what is the chemical reactions, or whether it has to be undergoing where it has to dip in some particular chemical bath, right? And what are the raw materials to be chosen? Some kind of iterations are also going to be there. So where there is no proper fixed continuous the details are not fixed, so continuous operations are not fixed, number of operations are not mentioned, right? So such things where there is going to be a continuous changes, okay? But we are going to focus more about the discrete part manufacturing, because that is the most widely used, because before any product that is going to be is going to be manufactured, okay, all the data from the CAD file, then the analysis is going to be done, and then the sequence of operations are going to be determined. All these things are going to be finalized in the initial stage itself, okay? So that is the reason why we are going to give more importance to discrete part manufacturing rather than continuous process manufacturing, okay? So yes, so what is going to happen is that when the design is over, okay, and it is passed, so it is whatever according to the application, okay, the part is going to be subjected for design, process, and analysis, okay, and then the manufacturing, and it is going to be passed on to the manufacturing department. So now what happens over here is that the process planner converts the design descriptions, okay, and the parts are all the assembly in the production instructions, right? So now what is going to happen is that they will, what we actually see onto the screen when we do CAD modeling is only about the 2D drawing or the 3D drawing and assembly of the parts, right? And then about the analysis that has been performed by the analysis team. But after that, once it is going to the manufacturing department, okay, now in this manufacturing department, we have various sub-departments that we can say. So one is the machine shop, okay. The other one is about the tools required for the processing, which machines has to be utilized. So all these things comes into picture, which has to be done by the process planner, Okay, how should this product be processed, right? So this planning has to be done, right? Whether it is on an individual part or whether it's about the assembly of the parts in a production shop. Okay, right. So let's go to the diagram that has been given over here, which gives the overall view of the discrete part manufacturing, how it takes place. So let me just enlarge it. Yeah. Yes. So now, so now when you go to discrete part manufacturing, what is there is that, so all these things that is going to be there, starting from here till here, is all the manufacturing process that is going to be involved for a product in general. So before this, the CAD file has to be prepared and the design and analysis has to be finalized. So after that, whatever the data that is going to be received is going to go to the process planning department, where they have to first do the operation selections. What are all the operations that it has to, the part, on the part, the operations has to be performed, like drilling, milling, right? And in milling also we have different types of milling, face milling, like slab milling, then operate, whether we have to use a lathe machine or any other special purpose machines, right? So all that things has to be decided. And then, so after deciding upon what are all the operations that the part or the raw material has to undergo to get the final product, right? After that, what should be the sequence of operations that has to be carried out? Okay, now I'm just talking only about for one particular part, not about the assembly, right? So for one particular part, okay, what are all the assembly? Now if you take, the operation sequence. Now if you say that it has to undergo, say for example, if we have the body of the engine, right? So the body of the engine has to undergo slab milling, okay, and the edges has to be finished without any sharp corners. Then it has to also undergo so many different types of drilling operation. In some cases only normal drilling, in some cases it has to go boring operations, in some cases it has to, in some parts it has to go for for drilling for only a particular depth, not for the complete end to end. The drilling has to take place, right? So what should be the sequence of all these operations? Okay, right, right. So that sequence has to be determined. Now, if you do it in a different manner, then we will not be able to complete. So just for our simple understanding, in the machine shop, when we have used lathe operations, okay, the first thing that we always do is the facing operation, and then we do the plane turning operation, and then subsequently, depending upon what is the part that has to be created, then the third step will be depending upon if there is a knurling, we'll go for knurling. If there is no knurling operation at all required, then we will go for the next operation. That it can be depending upon the part, it can be a taper, turning, or it can be threading operation also, right? Right. So like that. So what? But in this case, if we change the sequence, then we will not be able to get the product in the right manner at a quicker pace also. So there will be difficulties. So that is why the sequencing of operation is also important. And the next thing is that the design and procurement of tools and fixtures. Now, for this, say for example, even if we have an engine body itself, okay, and for this, I'm just drawing in a very simple way, where here we have 3 piston that has to be located, right? So to hold this engine block during these operations, right? What are the tools that is required? How many types of drill bits are required, right? What should be the size, right? And boring tools and any other tools that is required. All these things has to be decided. Then what about the jigs and fixtures? Now to do these operations, this block has to be held rigidly during the operation, right? So how should it be held? Where should it be clamped, right? So do we need any types of jigs, or which jig has to be, or fixture has to be used, right? So all these things has to be planned, right? So what are the holding devices in general, if we have to say, right? So all that has to be set up. So this jigs and fixtures department is another department. So for every part that comes into picture, they start deciding on how the part has to be fixed, or can we make use of a jig because it's a repetitive operation, right? And what type of fixtures has to be done, and they start designing the tool designing, they call it as, okay, right? And then if there is from all these things, right? So especially operation selection, tools, jigs and fixtures, then comes the order material. What should be the amount of raw material required, okay? And what is the tools that we have to procure? Should we have to prepare any jigs or fixtures, right? All these things, material, all the other calculations has to be done. So all this is going to be done by the process planning department. And only after this, so now over here we will see, okay, this particular part has to go to a particular NC machine or a particular machine. These are the tools that has to be used. So if it is an NC machine in the production shop, then the NC programming has to be written, right? The NC programming has to be written, right? And it has to be checked, and only then the parts are going to be manufactured, okay? Or the raw material is going to be converted into either an intermediate product, finished product, or completely finished product. And once the product is being finished, okay, then it goes to the quality control, where sometimes computerized aided quality controls are also going to be there, where the parts are going to move either in front of a light source, especially like laser, where critical dimensions are going to be measured by the by these systems. And then is the packaging. How should this particular product to be packed, right? What are the features that has to be used, okay? And how should it be? So it's not only just wrapping this engine block with plastic sheets and cardboard, and how, and can we make it into pallets? So if it is going to be made up of a pallet, then how many boxes can we assemble? Where should it be? How should it be stocked, right? And shipping details, right? To whom should this be going, right? When should it go, right? How should it be, the shipping mode, whether through road or through airways, right? So all those means are to be done by the shipping department. So all these entire thing is going to be taken care by the manufacturing process team, okay? So for this, the major thing is from the data that we receive from the CAD and analysis that has been finalized. So after that only this process is going to start, where they're going to do the actual processing to get the physical product into the market, okay? Yes, so yes, that is what is actually explained in this particular paragraph in about the discrete part manufacturing, where the design description of the parts, assemblies into productions and into the solution also. So instructions to describe in detail regarding the manufacturing process, right? Okay, and that is to transform the raw material into finished parts, and subsequent assembly operations that is required to get into the final product, right? So for all this, the process planner needs to interpret with the engineering drawings, make decisions about how cuts should be made, how the parts to be assembled, in which order it has to be done, what is the order of operations that it has to be executed, what tools are to be used, do we need any fixtures and jigs for this, right? So all this is needed so that it is going to make it easier, so that the product can be done in a simpler way. The other one is that the process planner can make use of uh, uh, to uh, plan for these operations is by one of the thing is called as grouping them into families, that is using the group technology concept. Okay, right, that also we'll see in the later stages. Okay, what is this group technology? Yeah. So yes, so and here in the next paragraph they explained about the NC programming that has to be created and sent to the machine, and after that it has to be done by the quality inspection, packaging, right? All these things are going to be there, right? Okay, so now I have just told you about for a particular part that has to be machined, okay, right? Okay, now even if it is about the assembly, right? So if it is going to be about the assembly also, now in assembly what is going to be there in the assembly department, many different parts are going to be arriving from different vendors or from different departments where it has to be assembled. Now even if we take about, say for example, assembly of an engine, where the piston ring, connecting rod and all these things has to be assembled to get the entire engine, right? Okay, so if we have the engine body that is going to be received, then we have going to get the piston, right? And then piston rings, then connecting rod and all those things. So even there also what we require is what is the operation sequence, or nothing but the assembly sequence that we can tell over here, since it's basically related only to assembly features that we are talking about. So first thing, the piston number of pistons has to be taken, then suitably whether each piston has got two piston rings or three piston rings, right? So those particular type of rings has to be inserted exactly in that particular slots, right? And then the small end bearing should be placed at the other end of the piston with the piston pin, right? And then this assembly has to be going into the engine, right? So like this particular sequencing operations is there, right? So during this operation, do we need special type of jigs and fixtures so that to hold these things, and so that the parts can be assembled in an easier manner, right? So again, almost the same kind of things also comes into picture, whether it's about assembly also. So irrespective of whether it is going to be about the uh, uh, operations for a particular part, or even for an assembly also, the same things comes into picture almost. Yeah, right. So this is all about the discrete part manufacturing. So now going to the process planning. Okay, so now in the process planning, what do we need is that, as we have just seen, okay, so there are so many parameters that has to be established. Okay, now just from the manufacturing facility, the parameters that they have to use for all the machining operations should be clearly given. Now when we receive the CAD file, it will only have the dimensions, but what is the surface finish, what is the tolerance limits, right? And in what sequence should the part be moving, what should be the raw material size, all these things will not be there. So this has to be done by the process planning department. So now the goal is to convert the rough billet or the raw material into a final form. Okay, so from the engineering drawing, it has to be prepared by a detailed drawing. Okay, a detailed drawing has to be done. Okay, right. So in process planning, it has to be defined, okay, by preparing with all the working instructions, which machine should it go, how should it be assembled, all these things has to be given, because this sheet is what is going to be passed on to the manufacturing or the machine shop and the assembly shop, where they are going to perform the particular sequence and operations and activities as per the instructions given by the process planning departments. Okay. So the output of this process planning is what is going to be the sequence of selected manufacturing process or assembly operations. Okay, and that is called as the operation sheets or a route sheet. Okay, or also called by operation planning summary. In each industry, they call it with different names. Okay, now how does it how does this sheet going to look about? Just let's have a look at it. Okay, so if we take up any particular parts, okay, right. So every part in an industry will have a part number, okay, unique ID number, okay, just like how we have our roll numbers in institutions, okay, or an employee ID. Every part will have an ID. What is the part name and what is the date? Because the part, same part can be manufactured on different dates, okay, the finalized sheet, and there will be different versions, so date is also important. What is the material of the parts that it should be made up of, and what should be the size of it? Very much important. And then what are the operations, which machine has to be used for that? Okay, what is the stand-up setup time, that is to set up the workpiece into the machine, how much time does it require? All these things will be calculated. What is the amount of duration for the machining operation that the for that particular on that for the part on that particular machine it takes place. So all these things, as we know, we do it in the operation research. Okay, right. And then about so they'll give the instructions also what should be done. Okay, so in the chuck, material exposing 45 mm length should be there. So outside the chuck on a lathe machine, 45 mm of material should be present. Face has to be clean, that is facing has to be done. Okay, and then outer diameter, that is plane turning, has to be done for this particular diameter, for this particular length. Okay, and a chamfer has to be used or not. So in this case, a chamfer of about radius 2 is required. And what should be the speed at which the operation has to be performed? That is, the machining operation parameters will also be detailed. So the operator, by seeing this, he has to run the do the machining operations for this given description only, right? Okay, so after that, then after performing this, then the second operation is going to be on another lathe. Okay, again now this has to take some time, and this is the amount of machining time within which the worker has to finish the operation, right? So he has to reverse it, expose it for 45 mm, clean the face, right? And then he has to form a shoulder, form groove for this particular dimensions. Okay, and the tool that has to be used, a grooving tool. Okay, and all these things are also been described. So like this, the entire sheet is going to have the details for every part. For every part, all that operations that it has to undergo is going to be mentioned along with the drawing also, right? So this drawing is basically obtained by the from the CAD file. So for what should be the overall length, what should be the diameter, where should it be chamfered, right? what should be this distance from where the knurling has to be started and ended, right? And all these things, okay, here we have a threading, right? All these things are going to be mentioned onto this operation sheet. So without the drawing, only the description is not going to be sufficient. Yeah. Yeah. So yes. So this is actually our drawing sheet. So the drawing is the first that has to be incorporated with all other drawing details over here also. So here on the drawing sheet also, again we will have the part name, the part ID, right? The material, the scaling of the drawing, and all those things will also be mentioned over here. Right? Okay. So here, so whether it's going to be for operation of a part, or whether it's going to be the assembly operation, this type of operation sheet has to be is going to be used in every industry. And when it comes to assembly operations, the exploded view of all the parts will be shown over here onto the drawing sheet. If it is going to be an assembly process that they have to do, so an exploded view where there will be part list, okay, how many parts, part name, part numbers, all those details will be there in the part list over here in the on the drawing sheet, okay. And then in the sequence of operations, what will be there is that what is the first part that has to be fit, how should it be fit, right? So say for example, if you are going to take up so if you are going to have an engine body, and let us assume that this engine body, the piston arrangement and all those assembly is done. Now on this, the engine head is going to be placed onto this engine body, right? And then what is going to happen is that it has to be uh, assembled, where this engine head and engine body is assembled by nuts and bolts, okay, where particular sequencing is going to be done. Which nut out of this should be done first, should be inserted, okay, by how much it should be tightened. So they have to make use of a torque wrench. So they have to maintain the torque only, right? So what should be the torque that has to be used, that will also be mentioned onto the drawing sheet. So then will come which should be the next part that has to be assembled. Okay, how much should it be tightened, right? And how it has to be moved, right? How the alignment has to be checked. All those details will be mentioned onto the into the operation sheet, along with the assembly drawing that is going to be provided for the assembly department. Okay, right? So this is how the operation sheet is going to be there. So many factors are going to influence the process planning, whether it's going to be for a part or for an assembly. Okay, and what is the geometry, what is the accuracy that is required, and the surface finish that it has to be obtained for machining operations on a particular part. All these things has to be done, and the material has to be used wisely. For very smooth finish, okay, then it has to go in for grinding operations also, right? So some kind of lesser final less finishes, then it can be obtained by the by doing the operations onto the using the machines itself, right? And similarly, the quality inspection people will also receive the drawing sheets and the quality inspection, which are all the uh, dimensions that have to check whether the knurling has taken place properly or not, right? And very, very critical dimensions and other uh, features also they have to check, and they have to make a record of that, and the part is going to be passed or not. So sampling techniques are going to be used over here, right? So like this, each department is going to receive every set of details clearly described along with the part file or the drawing file that is required for them to do the required processing. Okay, right? So this is how the process planning is going to take place.